The following is an AZPM original production.
Arizona Science is supported by Research Corporation for Science Advancement.
For AZPM, I'm Leslie Tolbert, Regents Professor Emerita in Neuroscience at the University of Arizona, and this is Arizona Science. Our guest today is Ying Hui Chou, Associate Professor in Cognition and Neural Systems and Director of the Brain Imaging and Transcranial Magnetic Stimulation Laboratory. Thank you for joining us.
Thank you for having me.
So start by telling us a little bit about your background. What drew you to studying the brain?
I was drawn to the study of brain aging out of curiosity about how our minds evolved during our aging process, and a commitment to unravel the mysteries behind conditions such as Alzheimer's disease.
And you use very specialized, highly technical instrumentation to study changes in the brain with aging and even to stimulate improvement in brain function as we age. So tell us about that.
To assess brain activity, we utilize something called Transcranial Magnetic Stimulation, or TMS. TMS is a non-invasive brain stimulation method that applies Faraday's principle of electromagnetic induction to activate neurons in targeted brain region. And the FDA has approved multiple TMS devices and protocols for the treatment of conditions such as depression, migraine, OCD, and smoking cessation. So we want to apply this technology to enhance memory function in people with mild cognitive impairment and Alzheimer's disease.
You see differences in brain function that correlate with mild cognitive impairment, and then you can use TMS to try to change basically pathways in the brain, I suppose.
Exactly.
And you do find that you can get improvement. So what would a person find he or she could do after the TMS stimulation that wasn't possible before?
We usually just interview our participant, asking them how they feel after our treatment in our experiments.
And do they report having stronger memories of recent events?
They feel like it becomes easier to memorize things or have better sleep. So I feel like sleep might be something in the future we want to target. Maybe it's because we somehow change the sleep pattern and they have better sleep quality, can consolidate their memory better.
So you're able to slow down the progression of cognitive aging. Is this true for a special kind of memory loss or for a special subset of people, male versus female, for instance? Or do you have a more generalized effect that you find across your studies?
Very great question. So currently, we haven't really identified which population would be the best target for our TMS protocol. So in one of our NIH-funded project, once we finish all the data collection, we want to see what's the characteristics or baseline brain network characteristic can be used to predict who will benefit from which kind of stimulation protocol. So in the future, we can personalize the stimulation protocol to fit everybody's need.
As a neuroscientist who worked at a cellular level, I just can't imagine how particular pathways are being influenced in the ways that you're finding happen.
Yeah, we actually want to target the hippocampus. And we actually published an article in PNS. Mm-hmm. We reported that stimulation can actually increase the connectivity around the hippocampus and also enhance associated memory function.
Well, that's very exciting. That's something that dreams were made of a decade ago and 5 years ago, and now here you are doing something really, really spectacular. Thanks very much.
Thank you. It's my pleasure.
Ying Hui Chou is an expert in the use of high-tech procedures to study and even improve brain function, especially in the aging population. You can listen to this and all Arizona Science conversations at azpm.org/Arizona Science. I'm Leslie Tolbert.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science. AZPM podcasts are made possible in part by donations from listeners like you. Learn more at support.azpm.org. Thank you.